Hey everyone, welcome back to Code with Me. In today's session, we're going deep into structures and unions in C. By the end of this video, you'll understand how structures and unions work, how to use them, and the key differences between them. We'll also write some real-world programs to see them in action, like storing student details using structures and optimizing memory using unions. So let's get started. All right, let's first talk about structures. Imagine you need to store information about a student, like their name, age, and marks. One way is to create separate variables. Char name 50, int age, float marks. But what if you need to store details of multiple students? Managing separate variables for each student would be messy. That's where structures come in. A structure is like a container that groups different variables together under one name. Think of it as a folder that holds related documents. Here's how we define a structure. Struct student, char name 50, int age, float marks. Now we have a student structure that contains three fields, name, age, and marks. To use it, we create a variable of type struct student S1. We can assign values like this: pi s1.name John, s1.age 20, s1.marks 85.5. And to access the structure members, we use the dot operator. Printf name sent sn, s1.name. Print age sent age. Marks sent.2f, s1.marks. Now, let's write a complete program to store and display student details using structures. Tasha includes stdio.h, include string.h, struct student, char name 50, int age, float marks, int main, struct student s1, print enter name, gets s1.name, print enter age, scanf d, and s1.age, print enter marks, scanf fy, and s1.marks, printf n student details n, print name sent n, s1.name, printf age, printf marks sent.2f, s1 marks, return 0. In this program, we first declare a structure and then use gets and scanf to get input from the user. Finally, we print the student details. Now, let's move on to unions. A union is similar to a structure, but with one key difference. It shares memory among its members. Think of it like a single storage box that can hold only one item at a time. Here's how we define a union. Union data, int I, float f, char star 20. Now let's create a union variable and assign values. Union data d1, d1.i equals 10. Printf integer sent in d, d1.i. d1.f equals 314. Printf float sent.2f d1f. Stark pi, hello. Printf string sends n d1 to star. Now here's something interesting. Since all members of a union share the same memory, when we assign a new value, the previous one gets overwritten. Let's see this behavior in action with a complete program. Include stdio.h, include string.h, union data, int I, float f, char star 20, int main, union data d1, d1.i equals 10, printf integer then d1.i, d1.f equals 3.14, print float sent.2f d1f, str pi d1.star hello, printf string sent n d1.str, printf and notice how only the last assigned value is correct, return 0. This happens because all members share the same memory location, so only the last stored value is valid. Now let's discuss the differences between structures and unions. 1. Memory usage. In a structure, each member gets its own memory space. In a union, all members share the same memory. 2. Usage. Use a structure when you need to store multiple values simultaneously. Use a union when you need to store one value at a time and want to save memory. To demonstrate, let's compare their memory allocation. Struct student, char name 50, int age, float marks. Union data, char name 50, int age, float marks. Int main, print size of structure, set lu bytes, size of struct student. Print size of union, set lu bytes sends, size of union data, return 0. You'll see that the structure takes more memory, while the union takes the size of its largest member, saving space. So, when should you use structures and when should you use unions? If you need all values stored together, use a structure. If you need to store only one value at a time, use a union. And that's a wrap for today. If you found this lesson useful, don't forget to like, share, and subscribe to Code with Me for more in-depth programming tutorials. See you in the next chapter.